Create the marker to start to split out the video. All right, so making our player fall down. Let's see. So, okay. So implement default for entity affected by gravity. What are you upset about? Oh, missing physics system. Physics system is going to be none by default. Oh, well, that was it. That was our two errors was that one thing. Oh, no, wait. Come on, Rust Analyst there. Be faster. Okay, so we have physics system here. Cannot find that. Let's go ahead and... oh, right. We haven't actually created a physics system yet. That's another big reason why we don't have that in here. So we need to fix that. New folder. Physics system. mod.rs. Yeah, so when we create new modules, if it's a folder like this, the first file is like mod.rs. That's just what it has to be. And it's very similar if you're used to JavaScript and Node.js, that folder being index.js inside of a folder, and then you could just require that folder in. It's exactly the same thing here. Okay, so before I actually write any code in here, let's come to you, and then we're gonna mod physics system. Now, we still need to actually create you. So in here, we're going to do a hub trait physics system and not have anything in to begin with. Lord Mist, hello. You'll have your stream open in background since you're doing homework. Oh, well, good luck with your homework. Which class are you working on? I guess you're lurking, so it's probably not fair to ask you questions because that's going to distract you from your homework. But good luck with that. Hope you get a good grade on your course. All right, so we have our physics system here, which means we want to pull that in here. And then you're all happy here, maybe? Right, we have to implement this debug. So we remember how to do that, which is as part of this trait, we're going to say where self, and we associate self with debug. We have to have it be standard format debug. And that should make it, yeah, that makes it happy over here. So now the next thing is this apply force. Physics system does not implement apply force, and then world oh, okay. So gravity here, where we have this as a 0.2. Now this isn't satisfied by default, but I think we can fix this maybe a little bit by having a config. And then the config can it can grab this information out. Not sure what it's called in English. Oh, just got to fill out a table on religions. So probably religious studies. I took a few religious studies classes in anthropology courses when I was in college. So I don't know if it's even close to similar to what yours. Oh, ethics or something in German. Oh, interesting. Oh, yeah, ours definitely wasn't about ethics. Ours, the one I took was more of historical and comparison of different viewpoints. It was probably the worst grades I ever received. I was terrible at that course. It's more religion than anything else, though. Oh. Well, it can be interesting to sort of see all the different viewpoints. But those classes can get a little bit heated sometimes in discussion if they discuss religions that people in like taking the course are participating in. All right, so unfortunately, gravity here doesn't derive default. Now what I could do is I could have gravity passed in here, or more likely we probably should implement default ourselves. So input default for world, and then we can say, okay, let entities equals just a new empty vector, and let gravity equals, and so I'm going to do this right now, but eventually I do want to use a configuration in order to do this. So this is going to be a point to there is no new like that, so x is 0.0, y 0.0. Return self, which is entities grab, and that way we don't derive u anymore. Okay, so then down here, right, okay, so this test where we had world.gravity, when we add gravity to the world, I don't know if we necessarily need to test this specifically. It's just like the type system is like, do we have that in there? We do. Oh, wait a second. Oh, it's because it's set gravity. Hold on. Never mind. I know what I'm doing. Gravity is this 0.2, this n algebra 0.2. And then what I want to be able to do is, in default, we set this to 0. Then you become fine. Okay, so never mind. So this is, gravity is now, I wonder if we can compare this. So 0.2, x is 0, y is 0.0. I wonder if you're going to be okay with that. Oh, you are. Okay. You are a 0.2, x is 0.0, y is 5.0. Okay, so we're happy with that. We don't have an update here yet, so that'll be coming. All right, so next is apply force. Now it's saying, hey, there is no method named apply force on a physics system. Well, that's because we haven't created it yet. So before I add in apply force, let's create our player physics system and sort of like go with that. So it's gonna be a player physics system. I don't want you to be capitalized. And we're going to mod that. Okay, so mod player. I also want to make you consistent naming wise with everything else. Player physics system. Apparently I'm more tired than I'm sounding. So player physics system. And now that will allow us to start doing these things here. So we're going to have a pub struct player physics system. Now, I'm sure we're going to have to, like have a velocity and acceleration as all part of this. So we're gonna include that here. But we're also going to implement. I don't know if I can implement default for a player physics system. I don't even know if I want to. Probably, or we can just do a new. I'm thinking we're gonna have those point twos or vectors. Because we can store them as vectors, and that would allow us to do some vector math, which might be really nice. So here, we know if we want something to fall, we're going to have an acceleration, which is going to be a vector 2. Now, here's this mint vector 2. I haven't tried these before. Let's grab that. We'll have a velocity, which is also a vector 2. And the location is actually stored on the entity, so I don't need that. It's going to be passed into the input loop. So I don't know if we need anything else with this. Now vector 2s. Let's see if they implement default. I'm guessing not, because the other ones did not. So derive alt. Yeah, okay. So it doesn't satisfy default. So we can control default for player physics system. All right. So that acceleration equals, this can be a vector 2. Where? That's not really helpful here. I don't think vector 2s either have new. Because I don't think I'm going to be able to do this. New, like 0.0, 0.0. Yeah, no function associated with this. So can I do something like this, where we have x is 0.0, y is 0.0. You are happy with that? Okay, perfect. Now I'm curious, can I do something like acceleration plus like 5, like a scalar? It'd have to be like 5.0. Can I add a float? Okay, so can't do that. Let's create the next one. So this is going to be our velocity. Now, can we add these two together? So we could say acceleration plus velocity. Oh, they don't have that. Okay. So I could use an n-algebra vector too. Which I know that GGEZ wants to go away from, but if I do that, I get vector math. So let's actually replace this. I'm going to replace vector 2 with a import an algebra vector 2. Yeah, so what I want to do here is say vector 2 new, then this is going to be 0.0 and 0.0. And that creates a new acceleration. We're going to do the exact same thing here. And this allows us to have this type of vector math for us. So it's going to be really nice. Then we're going to return self with acceleration and velocity. Okay. then come back to here. Okay, so we need an apply force. So in physics system, we're going to have a, let's actually just do it the other way around. We're going to impl physics system for player physics system. And this is going to be so we're going to apply the force to it. So the force is going to be gravity. So we need to just take in a force. I think that's all we need to do. So we're going to have a function apply force. We're going to take in a mutable self and a force, which is going to be a vector 2. It has to be a vector 2. Let's actually do GGEZ in algebra, vector 2, F32, and we're not going to return anything. Instead, what we're going to do is we're going to take our acceleration and we're going to add our force to that. So that way, every single tick, we accumulate all the acceleration forces that are going to happen to that, and then all of those together affect our velocity. So we're going to say self.acceleration plus equals the force. And that's the real benefit of using n algebra vector 2s here. Now, you're yelling at me because I am like, this doesn't exist in the trait, but now that we know exactly what we want to do, we can come back to here and add you in. Oh, doesn't implement debug. So that's up here. Let's derive debug. And back to you. Okay, so we now know our forces have to be n algebra vector 2s. So not just 0.2 thing. We need you to be a vector 2. So that's going to be the n algebra vector 2, F32. Homework done. That was fast. But congratulations. It's always nice feeling that you good that homework is all done. Can I move out of self the okay, right. So I don't want to actually take ownership of these. So mute. Well, you did start. Okay, you did start before joining the chat. Yes, I can believe that. Otherwise, it's gonna be like really fast. Okay, so then you're happy here. I'm kind of surprised. Is it because we haven't called apply force yet? I think that's why. So we have our update here in an entity, but in our world, we don't have an update loop here. So our gravity is going to have to be a gravity force, and we're going to want that to be affected by. Let's see. So this 0.2, we need to change you. We don't want you to be 0.2s like this. We want you to be a vector 2 from an algebra and F32. To create this, it's a new. Whoa, I still don't want to be multi-cursoring. Okay, so new. Open U. Don't have an X. Oh man, this is like slower than if I just did it on my own. Okay. There. Okay, that gives us a gravity. That makes you happy here. Then you are all. So let's just do this in one go. So we're gonna do gravity equals a vector 2. Then, okay, so you should be equal to this. So you're going to be gravity. Then we set the gravity to 5. So we're also going to want you to be mutable. So that way we could then say gravity dot y is equal to 5, 5.0, and then you are gravity. Okay, nice. Then we want our update. Before we do that, are we resetting gravity here? Because we're creating, okay, we are. We're setting gravity to 1. Now the next thing is we need to update the world to make the circle draw. And so if I run this, because we have written a bunch of code. We should still see our circle, but of course it's not going to fall down yet. We want to now have that, like, apply the gravity in. We have that all set up, I believe, in the world, in the entity. It's going to apply the gravity force that's passed into it when update is called. So that means the world needs to have that. Let's do that here. So pub function update. We already have gravity in here, so I don't actually think we need anything else. We're not going to return anything. What we are going to do is we're going to loop through all of our entities. So self.entities.ittermute. We can just do a for each entity. We see that it is a mutable reference to an entity, so we're good to go here. And we're just going to do entity.update and hand it a reference to self.gravity. And you are expecting to take ownership, aren't you? And we don't really need you to take ownership. So back to entity. You should be a reference here. And then back to our physics system, or a mod here. You should be a reference. And then in player physics system, you should be a reference. And then we can see self.acceleration is plus equals to force. Okay, perfect. So then next up is going to be update. We need to update our physics system when during this time. So like when an entity updates, also update the physics system. Okay, so where is that going to be? So right here. Self. I don't know if we are going to need a location. So we're going to need a location, and this is going to be a reference to a BGEZ. Actually, you know what I can do? I can do a reference to a rect and then qualify. And I think that's all we need right this second. We're probably going to need more. Okay, so we've applied all the forces externally to this, like gravity. Then we want to add our add the acceleration to the velocity. So we're going to say self dot velocity is going to be plus equals to self dot acceleration. That updates our velocity. Then I want to say self dot this location. Okay, so you need to be a mutable reference. And location dot x plus equals to self dot velocity dot x. So we have to do this one a little bit manually, but it's not that bad. And then location dot y plus equals to self dot velocity dot y. And can't forget this, we have to reset our acceleration for the next time. So self dot acceleration times equals 0.0, and that will reset ourselves. Okay, let's go ahead and implement this in here. Okay, so then in world, cannot borrow self as immutable because it's also borrowed as mutable. All right, where is that happening? So mutable self. Oh, right here, because we're grabbing this gravity. So one thing that we can do is we can clone gravity and then pass that in. I'm also curious. Could I just get that gravity equals a reference to self dot gravity and then pass that in? Would that make you happier? Yeah, it does. Okay, so I just borrowed it here, and then we run the rest of it here, and then it's fine. So it's just a little bit of a rearrangement of code to make the borrow checker happy, and then that's all good. Okay, so we have to call update. So let's move backwards here. We have our player physics system with update, and that's going to update the location according to the gravity that we're applying to it every single frame. If we go backwards from that, we go to the entity. In update, if we have a physics system and we're affected by gravity, then apply the gravity force to the physics system. And we also have draw, which hands it the location, which is going to draw that. Okay, that's good. Then we move backwards one more step to the world. And we have update here, which goes through all of our entities and runs update on them, passes them to gravity, which means we need to go all the way out to the main library. And in update here, I'm going to update the world with self.world.update, and that's it. So that is our circle update. How long should we wait until we see if it moves? I don't think it's working. Did I actually set this circle as being affected by gravity? I don't remember. It should move pretty fast because I don't have an FPS limiter on yet. Okay, so what are we doing here? We want to go into when we create the entity, so that's in our world. We have no entities. Okay, so we have an add entity here. So it's actually in the main library. Sure Shock, hello! You redeemed Pet the Kitty. Let me go see if Kitty Cat's just right out behind the green screen. No, he's not. Sorry, Sure Shock. Also, hello. I'll leave the request up just in case he Zilly does come by and say hello, then we'll do some petting of the kitty. Unfortunately, the kitty cam didn't load today, so I can't turn that on, so you can't see that he's not here. So in our main library, okay, we create a new thing here. So player, set location, set draw system, and that's an entity default. For an entity, we have this affected by gravity. You know what we don't have? We don't have a toggle to be able to turn on affected by gravity. It's kind of an oversight. Let's add that in. So test CI test making entity affected by gravity. So we would expect that we have a mute entity defaults, and we assert equal entity dot affected by gravity is false, and then entity equals entity dot. Actually, you know what? This should probably be a toggle. Is that true? I don't necessarily think that I want to toggle this one. Yeah, okay. So I think we should do this as part of the builder pattern. So entity dot set affected by gravity. So I think that if I do this, I think then we can just say, okay, entity dot affected by gravity should now be true. And then all we have is a set affected by gravity, and that really just, yeah, we're now set. Now I could pass in true, so that way we're being extremely explicit. Also, that allows us to turn it off at a later time if we want to. Okay, so import entity. So I'm going to put this right by the other sets. So pub function set affected by gravity. This takes ownership of itself. Affected by gravity. Boolean. Yeah, I think for right now, I'm actually going to not pass this in. Now allow me to just do this. We're going to return self. We're going to say self dot affected by gravity equals true, and then return self. Okay, so you're happy test wise, which means that when we create this player, we can have this. Oh, we set the draw system. Oh, we also need to set the physics system too. We can't forget that. So then set affected by gravity, and then set. We don't have a system to set a physics system. Well, that's kind of important. So let's add that in next. So CI test add player physics system. All right, so let entity equals entity default. We're going to just assert. We're going to use that matches again. So matches entity dot player physics system. Oh no, just physics system. Physics system, you should be a none to begin with. Then we're going to set the physics system. So entity dot physics system, no. We dot set set entity equals entity dot set physics system, and then we're going to pass in it has to be a box new, and it's going to be the player physics system. So player, here's UR, and then default, and then that's that. Then we can state that the entity should now match that. And I'm not sure we can. We can reach into it and see if it holds like one of those things that we know that it holds. But I don't think we have. I wonder if I can like. Yeah, I think this should really. It should no longer. Oh, okay. That's what we can do. We do this that it's no longer a none, and then a type system. The type system holds the rest of this. So physics system is no longer a none. So set physics system is next. Okay, so physics system is going to be a box with a Dyn physics system in it, and we're going to return self dot physics system. So it's an option right now. So this has to be a sum physics system, and then we return self. So that should make you happy. Perfect. Then we can come back to the main library. We have set affected by gravity, and then next is dot set physics system box new. This is gonna be the player physics system default. So if I do that, does it work? Still no. Okay, so we've set you to be affected by gravity. We've added a physics system in. We've added the player. We know that we've added the player because we actually have this player showing up here. We're updating the world, and we're drawing the world. Let's go in and make sure that it's actually being called. So in our player physics system in update here, I want to just make sure that we get a debug, and maybe we can just take a look at like the location. And a reference to the location. Don't want to take ownership of you. No, don't want to cargo test either. Cargo run. There's our problem. Okay, so we're not calling the physics system. So how do we fix that? Let's trace through here. So in our main library, we have our world. We create our player. We add the player to the world. We know the world. We know the player is getting there because the draw part is working. So this self-to-world draw is working for us. Now we have self-to-world update also happening here. So let's head into world. And we have update, which takes an immutable self. We extract out a reference to gravity here, which gravity is 0, 0. Well, okay. We're trying to set gravity, aren't we? Go back to the main library. We can see set gravity. Okay, so gravity is being set. Then we for each through all the entities, and for each entity to update and pass in gravity. Okay, fine so far. Then that means we head to entities next. And with entities, we have an update, take in a gravity, which is that vector. If let some physics system equals mute reference to the self physics system. Okay, so if we get the physics system out, and we should have one from the player. And then we check to see, are we affected by gravity? And if we are, then apply this force. But you know what we're not doing here? We're not calling it normal updates. We are applying this force. But if we have a physics system, we should also, after we apply the force, just run update normally. So this is going to be a physics system.update. We have to pass it a reference to the location. So that's going to be self.location. And that's it. And our location is this rectangle. Oh, and it needs to be a mutable reference. All right. Let's try this. That was a bit fast. So let's maybe not be that fast. Look how far down it got. In that small amount of time, we are 2,931,881 pixels down in the world. That's that traveled really far, really fast. We're gonna want to, well, first of all, probably our gravity is quite possibly just a little bit strong. Just an idea. Now, if I want to, control how fast things are moving, that's going to be in our main library. In our update, we need to control the rate of this update. So this is going to be a while timer. No, it's check update time here. Hand it to context. And then our target FPS. So if we set this to be 60.0. And then we only update the world while this is happening. So this computer is really good. It's going to be able to keep that 60 frames per second. Oh, you need to be a U60. Yeah. It's going to try to check to see, has 60, have we run 60 frames since the last time? No, in the seconds. And if the math is wrong and like we've gone what so like point 0.166666 repeating is like how much time in milliseconds we have. No, 16 milliseconds, I think, or 12 milliseconds, something like that. If we're slower than that, it's going to skip running this time, and then next time it'll run the loop. And if it's more than that, it'll run it multiple times, so that it might like just update in a chunk. So no matter what, it should be relatively smooth unless our computer lags really bad on the update side. So if I do this, we're now going to get consistent move time, and that the numbers that we have are going to make a lot more sense. Still really fast. So let's actually set our gravity to, instead of 1.0, let's set it to like 0.01. And there we go. Okay, so now it falls a lot slower. So probably gonna want this to not quite be as slow. So maybe 0.1. And this is where we probably want to start thinking about, that feels a little bit better. Once we get a jump in and we can see it like the gravity fight against the jump force as we go up, that might actually help out a lot in like determining what our gravity should be, how far we should be able to jump, have some like chasms that we can jump over. But that gives us an entity, and it gives us it's now falling down. Okay, so that's all and great. I kind of want to set a config up for this in order to control what these numbers are. So I'm going to create a folder for this. I'm going to call it a config. And mod s, our main library. We're going to So this is an interesting question. Who should load up this file here? Should it be main that loads up this file? Because eventually we're gonna be wanting to go out to the to disk to get it. We have a context here. It wouldn't really be part of a problem to like do that right here. So let's just do it all here. I'm gonna do mod config. So here's my idea. We're gonna want a pub struct config, and we're gonna throw in those like whatever structures that we really feel like we need to have in here. So we can have like a target, target update FPS. It's gonna be a, what were you? A U32. Okay, so you're a U32. And then we're also gonna have a gravity. So a gravity force, which we know is going to be a vector, an n algebra vector 2 of F32. Now is that true? Is that how we're doing this? Set gravity. Oh, actually, we're doing it like this. So you can just be an F32. Yeah, it doesn't really make sense for gravity to be affecting like left and right, does it? So we shouldn't even give ourselves the option of doing that. Okay, so we have, these are the two things that are part of our defaults that we really care about here. And then we're going to have a default. So simple default for config. And okay, so here we can do our let target date. Yes, you're gonna be a I think right now we're gonna say like 60. And then eventually we're gonna want to grab out your U32. We're gonna want to equal sign to. We're gonna want to grab out from disk and have like a JSON file or a TOML file or anything else. But I can delay that decision about how we're gonna grab this from disk until later by just having the default here, and then we can sort of load that up at a later time. Then we can tweak them easily without having to recompile once we get to the point where we're able to design games, as opposed to just building out the basics. Now we get to spend the time on, what's the most important for us. All right, so let gravity force is going to be equal to, I think something like 0.0.15 is probably good for us. It doesn't really matter right now because we're going to have this controlled by a file. So then we're going to have our target update FPS and our gravity force. And this will allow us to make changes to this really quickly without having to change it in multiple places. Just in this one. All right, so if we have this config, then the first thing we want to do is load the config in here. And we need that at this point in time. So we need a let config equals config default. And I'm curious like how I want to set that. You can remove the import of vector2 now from config. Oh, did I? Oh yeah, I accidentally added that in too. Thank you to Grugalis. Then, now of course, we're gonna want to like load this later, and so we're probably gonna replace this from default to a load. But that's, we'll figure that out when it happens. Like refactoring in Rust is surprisingly easy. For at least this type of stuff. Okay, so for world set gravity, this is going to be a config dot config dot. Oh, all these need to be public. Gravity force. And down here. Okay, so if I want this, we need to store the config up here, or I need to extract it out and just store that here. So I'm thinking right now, I want to pull everything out of the config at the beginning of holding it. So then like the config will just be dropped after we start running, and we're not going to be having to pass the config around, because when I was working with the jungle game, that was like, it ended up actually becoming much more of a hindrance than I thought it would be, passing that config around. We became like just having it. It was everywhere, and it would cause problems for testing too. So let's actually store our target update FPS is a U32 here. So target update FPS, and then we'll add the U in here. You're curious as to why is such a low gravity move so fast? What's the world distance from top of the screen to the bottom of the screen? Good question. We can find that out. We haven't yet made a grid, which is going to be really nice for us to like draw a grid out, which is going to be then we can set what that is going to be in our config, and then see that like see it moving. So Now, I am trying to update that acceleration, but there is no cap to our velocity, so it can just go on forever. And it's possible that our 60 is maybe too fast for us. I don't know. Let's go ahead and run this again. So go run. So that drops, and that looks nice. We see it updating as it's just going crazy down. We don't need that debug anymore. Okay, so what is the world distance from the top of the screen to the bottom of the screen? Let's check that out. So here in our game state. Now we actually should be setting that here in main. I believe we're setting this to 1280 by 720, but just to be sure, let's go into our main library, and when we call update here, let's get like the drawable size, so that actually we can just do this here. Screen size equals, and I want this to be drawable size and the context, and let's debug the screen size. All right, so should be able to now run this, and we're going to see what this screen size is. And so 1280 by 720. Okay, so that is correct there. I'm curious just to make sure that the first time this runs, it's what we think it is. So I'm going to run this debug, and then I'm going to panic to quit right away. And we're going to see if it's still that 1280 by 720. It is not. Look at that. Screen size is actually 2560 by 1377. To begin with. So it flashes, and then it sort of resets for us. But then, immediately afterwards, it resets properly. Now, I wonder... Oh, what happened? What link did you try to post? Nightbot, see what happened. That wasn't even an update. Oh my god, come on. Hold on, let me where is it? Spam protection, links, options. Hey, I'm gonna whitelist self.world.update. That's oh, don't worry, Nightbot. That is okay. Now you should be able to type self.world.update. Okay, so what does self.world update look like? All right, let's take a look. So we have this one. Let's actually just grab self.world update for like the same thing, for grabbing the drawable size in world update. Basically, we're just taking the gravity that we have, and then we're telling each entity to update and adding in that gravity. So if we go to entity update, we come into here, and so for this update, we check to see if you have a physics system and you are affected by gravity, then we apply this force, gravity. So we just add that force in here. And so that's going to be every single tick. then we tell physics system to update. So if we go and take a look at either one of these, apply force, that's actually the trait. We have to go into here. Apply force is we're taking self-thought acceleration, which is starting at 0, and we're adding the force to it. Okay, so pretty standard. Then in update here, we're taking our velocity, which also starts at 0, and adding the acceleration. Then we're adding the location to the velocity to the location. And then we're resetting the acceleration. So it really should still be. So like, I guess what we could do is debug self-dot acceleration to really make sure that got reset for us. Because if it didn't, then that would cause it to be really fast, really quickly. And I need to go back to Matt. There, we don't want you. Where does delta time come in? Like frame time? Oh, yeah. So I'm not using delta time here. This thing right here limits us. So it's a slightly different system than delta time. So basically what's happening is it's looping. It's our ticks are going through as fast as the processor can handle them. And it's doing the math. And so what, 60 frames per second? Just do the calculation. Calculator. Okay, so if we do 1 divided by 60, that's 0.16. And so if we multiply that by, what is it, 1,000 times 1,000, this is the number of milliseconds. So 16.66. Okay, so it checks to see, I'm hardlining. Yes, thank you. 16 milliseconds. So if it's been 16.66 milliseconds, then it, since the last time it ran this, it will return true. Where's my update? Here it is. Where am I? What am I doing? Wow, C. What did I do here? There we go. Okay, so it's going to check to see, are we at 16.66 milliseconds since the last time we ran this? And if the answer is yes, it's been past that, it's going to run this loop. If it checks again after running this and says like, ooh, it's still been like, it's like we ran the loop and it's been not very long. It's been I don't know, like it was 32 seconds. It took us a really long time to get here. Then it will run the update twice. And then eventually it will say, ooh, okay, we finally caught up to our like 16 milliseconds every, 60 frames per second. Oh man, but I have to like draw it out every time that I like think about it. My describing it is terrible. If you need to determine a game, you should probably still use delta time because your game loop can take varying times, which can lead to unwanted results. If you don't care about 100% determination, this should be fine. Yeah, and like the nice thing about this is it makes it so that it's going to be consistent animation throughout. If our computer does slow down way too much, and for some reason there's like a huge wait in between there, it's going to loop through like 5 times before it exits out. And this is blocking. So it won't move to the next draw until it runs these X number of times. This is actually a big part of let's see, where is it? the game loop. So it's not, well, yeah, okay, event loop. So basically it's not exactly quite like this, where it's just process input, update, and render. You still suggest defining gravity in milliseconds and multiplying by 1/60. The thing here that we're doing is is basically we're updating the game at a very fixed rate. Now, what I would need to do to prevent any kind of tearing or any other like problems with that level is actually not an update area, but in the draw loop, I need to do that. So that would be in here. This is an excellent article on like how to fix the draw loop. He doesn't have any pictures to show what that looks like. Because what can happen is I can have multiple updates and they don't necessarily line up with our draw, and so it might actually be good for us to do this here. So at this point in time, we can, what is it? Easy timer. So this is the update. Wait, this might have a better description between this. Check whether or not the desired amount of time has elapsed since the last frame. This function will turn true if the time since the last update call has been equal or greater to the update FPS indicated by the target FPS. It keeps track of fractional frames. So if you want 60 FPS and a game stutters so that there is 40 milliseconds between update calls, this will turn true twice in a row, even in the same frame. Then taking into account the residual 6.67 milliseconds to catch up to the next frame before returning true again. The intention is for it to be called in a while loop in your update callback. So I don't have to like handle that. But there is this remaining update time. Returns a fractional amount of time of a frame not consumed by check update time. For example, if the desired update frame time is 40 milliseconds and 45 milliseconds have passed since the last frame, returns true and returns 5 milliseconds, the amount of time overflowing from one frame to the next. The intention is for it to be called in your draw callback to interpolate physics states for smooth rendering. So that's where this happens. So if I hand in the context, and we do let remaining time equals that. It's a duration. We can debug remaining time here. We can run to sort of like see what we're working with here. Wait. Player physics system, I left that in. We don't need a panic. Yeah, we don't need you. Oh, and our self-acceleration was resetting correctly. Okay, so we can see here that we're working with anywhere between like 10 milliseconds and microseconds, I think. And so what I can do is I can take this math, this duration, and figure out where to shift the draw. And I believe that's the other side of this, and that makes it more deterministic. I think that's my understanding of it. And I'm doing a very similar thing to what I Am Hardliner is doing. I'm just taking gravity as just a standard force that's always pointing down, and just applying that to our character, whoever is like affected by gravity every frame. And the gravitational acceleration is happening through just acceleration adding in theirs, but it definitely not realistic. I'm not necessarily going for realistic, more for like, does it look fun? But sure, Shock, if you're still here, we have a kitty cat. Hey, no bunny kicking. So on Earth, we can ignore gravity, the force. You just apply forces to acceleration. You apply the acceleration to the velocity, which finally gets applied to the position. Yeah, that's what I do. And I'm not calculating like mass of like what's below us and then affecting the mass by that. I've done a long time ago. I was reading through Nature of Code, which I never finished the book. I've started it twice on stream, and like have videos on my YouTube of me going through Nature of Code 2 or 3 different times. Doing different languages and different other stuff. It's kind of fun going through all that and doing and like learning how to make things look a lot more realistic. But I'm generally not worrying about it. I do remember reading through a game development article once that talked about how if you make gravity actually like work the way that it works in real life, it's usually not fun to play. Which is why if you watch like any of those game theories about like how strong gravity is, and like, oh, it's like 30 times Earth gravity, like how it looks, since that's just people are jumping like twice their height because that's just what looks right. I think there are probably situations where other systems would be better, especially simulations, but for a single platformer, I think the solutions to applying forces is better. I agree with you. I Am Hardliner. It would be maybe a lot of fun to do a actual realistic simulation at some point in time, and to figure that out. And like calculate what is real gravity. I haven't done too many of those simulations. That could be a lot of fun. It might require a different, it would require a slightly different approach here, because this is more for gaming and less for realism. Are you done being held? Now you just want to play? Ooh, I'll throw you a ball. Sylvie's learned fetch, so he loves doing it. Here's the ball that we have right now. You ready? Unfortunately, I don't have a camera down there. It's one of the things I want to invest in, is like a camera we can put out there that we can switch to and see him going and playing with the toys. You thought you Googled it? Oh, Mario uses realistic gravity? Interesting. I did not. Well, I guess he gets terminal velocity, doesn't he? Also. Now we couldn't do that. we could do that. Is have a terminal velocity as well, and that limits how fast down we can go. But I'm not sure I want to implement that. I think I'm gonna have to wait until I feel a bit, and sort of like see it. Now, if I want to have our player hit the ground, I don't think I necessarily want to hit the ground for this. I think eventually we're gonna want to. Let's see, let's run this again. I think the next thing is I want to add in a grid so that we can start putting in game entities like the actual floor in. Search for acceleration due to gravity. Okay, so hold on. Let me copy that entire thing. Let's search for it. Oh, like they actually have. Ooh, Mario gravity. Is this the one you were talking about? It's cool. This is that link. Now, if I want to, okay, I think we need to do this fix your time step thing. So before I get like way too off course, which always happens near the end of the stream. But okay, so in fix your time step, and we may need to finish this tomorrow. Multiple sites republished the same article. Okay, that makes sense too. Chantilly, hello. All right, so we have variable delta time. Free the physics part. Okay, so it's the remaining time. Render state, current state times alpha plus previous state's time. Ugh. I need to think through exactly how to do this. Oh, right. To understand what's going on in a situation where the display frame rate is 60 frames per second and the physics is running at 50 frames per second, which apparently is pretty common. Now, ours is like the display is running at like hundreds of frames per second and physics is running at 60. So we have the same exact problem here. There's no nice multiple for so accumulator causes the simulation to alternate between mostly taking one and occasionally two physics steps per frame when the remainders accumulate above delta time, which is what our thing is what's happening to us. Now consider that the majority of render frames will have some small frame time left in an accumulator that cannot be simulated because it is less than dt. This means we're displaying the state of the physics simulation at a time slightly different from the render time, causing a subtle but visually unpleasant stuttering of the physics simulation on the screen. Yeah, and I've implemented it once before, and then I forgot. I need to add it into my knowledge wiki, and then I won't have to do that anymore. Let's come here. So we have our remaining time in. One thing you have to be careful of, which he doesn't document, is that there's a cap to the accumulator. Interesting. Oh yeah, because we have this accumulator here. And I wonder if it's going to be easier. Because my accumulator is handed in, because I'm not creating my own game engine, but I'm grabbing it from GGEZ. So GGEZ is telling me, here's my remaining update time. So it's not the same as delta time. But this one is, so we use delta time and this accumulator. So whatever we are now times the alpha, which is really just the accumulator divided by the delta time, plus the previous state. Oh, so we now have to keep track of the previous state times 1 minus that. Now, I wonder if I can force some tearing in the game by setting our target FPS to really low. If I do something like self dot there, so to reset, we're using that. We go to our config and we set you to something like 5. So we're going for 5 frames per second. Oh, yeah. So I am hardliner. This isn't about physics. It's about the drawing. So what happens is like your physics is now set to like 60 frames per second. The math is all going to be consistent regardless of what hardware you're on. So you're always going to be able to like collide. You're not going to go between walls. But what might happen is you're over here. You've done multiple updates, and then you're at fractions of a frame, and you get these weird tearing. When you draw. And so if I set you to it really slowly, and we see tearing. Not really, unfortunately. Not sure exactly how I can like enforce it, so then I can make sure that it's working properly for us. Let's see. We can try something like try something larger than what we have right now. So if I do 1000, this is actually going to, I think, take multiple times, multiple draws before it does an update. Oh, well, 1000 is gonna zoom down the screen because it runs way too fast. So I do something like 50 or even 30, it should still look relatively smooth. I don't know if you saw that there was tiny bit of tearing in there. We could have it bounce off the ground, and then it might be easier to see. Or like maybe just like keep on adding more of these in. There was a tiny bit of tearing on one of them. But it's not consistent. It's like it's gonna be different every time I run this. It depends upon the processing, what's going on. I mean, we even see it in AAA games have these kind of problems. So ooh, you have a GitHub. Oh, and I think I have a GitHub is a link that is allowed. Let me double check. I'm pretty sure I'm allowing GitHub links. I wish this was in alphabetical order. GitHub.com. Okay, so yeah, if it's a GitHub.com link, Nightbot should allow it. Oh, that's someone else's library to be used with Bevy. Oh, nice. But it implements Gaffer on game's fixed time step. Oh, interesting. Is Bevy using a fixed time step? No, Bevy doesn't. You just query frame time. Okay. So I'm gonna have to think about like exactly how I want to implement this. Like I want to how the math works. And so maybe tomorrow we can sort of like spend the entire morning like actually figuring that out. We'll break out the WeCom tablet and do some math on it. So the gist of it though is going to be in one frame we're here, and the next frame we're right here. Draw frame that is though, but actually we should be in draw frame like going in between it very smoothly because we see that we are we're just sort of jumping, especially on the slower ones, and we want it to very slowly figure out like, hey, what's the like what should it really be, and we can see that when we update very slowly. Like at I think this 2, like this is gonna be really slow. And we want it to be less. We want it to be a lot more smooth, as opposed to chunk, 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 chunk. And that's what we're gonna be going for. But we're gonna be doing that tomorrow. Because I've got to head off to work. I've got a deadline today at work, so I can't work too close to the end. So I'm going to switch over to the ending screen so that nobody will raid me right when we're ending. Thank you everybody for stopping by and working. What is work? Yeah, I don't know. It's that thing that I go to get money so that I can do this every single day. It's fun too. No, work is a lot of fun. Anyways, we'll be back here tomorrow morning. We'll be implementing this time step. I do have all this code up on GitHub in case any of you want to watch it. I'll put a link. There's a link. Oh no, I have to update my code. Okay, never mind. I don't have a link. It's if you're watching on a PC, I do have this down in the GitHub save thing. I'll update this the bot tonight, so that way tomorrow the link will be correct. And then that way we'll be all good. And then we'll fix this time step and we'll go that one. Anyways, what do we got? Who's streaming? We've rated BeginBot a lot this week. I don't see anybody else online right now. So I think we'll just end it like that. All right, everybody, have a great rest of your day, and I'll see you all next time. Bye.